All right, so this one was 10. It said to write the polynomial as a product of linear factors. So you tested the possibles, right? You did all the possibles?
I didn't do so, I don't know how to do it.
Okay, so I'm going to look at the first of all, you want to make sure it's in order, a decreasing degree, which it is, right? And then the first number is 1, the last number is 5, so it's plus and minus last over first. Factors of the last would be 1 and 5, that's it. Factors of the first is just 1. So it's plus and minus 1 over 1 and plus and minus 5 over 1. So your possible roots are -1, +1, -5, and +5. So then you try those on the outside of your synthetic division bar. I would do 1, -3, 1, and 5. Bring down the 1, multiply it, put it in the next column, add it, multiply it, put it in the next column, add it, multiply it, put it in the next column, add it. And if there's a remainder of 0, then I know that that one is a root. So I know -1 is one of my roots. Then I'm going to take what's left. So this gets the x and this gets the x squared minus 4x plus 5. I would try to factor that first, and it's tricky because 5 and 4, they seem like they should be factorable, but that's a +5 and a -4, which means +5 means they have to be 1 and 5, which is going to give you 6, or -1 and -5, which is -6. So this isn't factorable. You have to use the quadratic. A would be 1, B -4, and C 5. So -4 is 4, plus and minus the square root of -4 squared minus 4 times A times C, all over 2 times A. 4 plus and minus the square root of 16 minus 20 over 2. 4 plus and minus the square root of -4 over 2, which is 4 plus and minus 2i over 2. Go one step further and reduce that to 2 plus and minus I. So when you go to list all your zeros, you get the -1 from here, and then you get 2 minus I, and you get 2 plus I. Those are the zeros or the roots or the solutions, right? That's if I listed it. Then it said to write them, or it says to write it as a product of linear factors. So I do x minus each one of those. X minus a -1 becomes x plus 1. X minus 2 minus I, and x minus 2 plus I. I just do the negative to remind myself that that gets distributed to both. So then it should be x minus 2 plus I and x minus 2 minus I. And then that's the linear factors.
You don't have to remember.
You're good? Okay, so but that's the one that has it repeated. So 2 worked, right? Like if you put 2 on the outside, 1, -4, 13, -36, and 36. Oh, wait, that's +18. That one worked, and then this is x squared, x to the 3rd. And you can actually factor this by grouping. So this is my other root, so there's 2 2's, and then I would try to solve this, set it equal to 0, x squared equals -9, x equals plus and minus the square root of -9, which is plus and minus 3i, and those are the other zeros. So I have 2 twice, which you're going to see today why that's important, and I get x minus 2, x minus 2, x plus 3i, and x minus 3i. Sammy. When you're listing them here, you don't need them both. When you're listing them here, you need them both. But you're going to see today why it's important that there's 2. So, I mean, it's kind of, you can put both. It doesn't hurt to put both, but you'll get points taken off if you don't have it in the linear factors. All right, so this is 3-2, which is called polynomial functions of higher degree. So this is where you learn how to graph those graphs that go up and down by hand. So the ones that look like a snake that go up and down and up and down, okay, you're going to want to be able to graph using a graphing utility, and you're also going to want to know how to graph using, like, without a graphing utility. So the first thing, and we talked about this a little bit right before the break, but this is called end behavior. And end behavior means what is my graph doing at the beginning and at the end. So where are my arrows pointing? If it's an odd degree polynomial, so if the highest exponent is odd, then my arrows point in opposite direction. One points up and one points down. If it's odd and the term on the front of that x is positive, so this is a positive x raised to an odd power, then the graph falls to the left and rises to the right. So falls left, rises right, and then it's going to do something in between there. If a is negative, so this is a negative x to an odd power, then my graph rises to the left and falls to the left. So it would rise to the left and fall to the right. So if you forget, like which one, what does even and odd do, picture your x to the third original graph. So your x to the third parent function goes up to the right and down to the left. If it was negative, it would flip. If the degree is even, so the highest exponent is even, then they have the same behavior. They either both point up or they both point down. If it's even and a is positive, so this is a positive x to the even power, then they both point up just like a natural parabola would. And if a is negative, then they both point down. Negative x an even power, and they both point down. Again, just like a parabola. If it was a negative x squared, it points down. If it's positive x squared, it points up. Now, the difference is this could be an x to the fifth, an x to the seventh, an x to the sixth, right? But the end behavior takes on the same. What happens in between is what changes. It could go up and come back down and go up and come back down again. And for that, we're going to find our max turning points and we're going to find our zeros. So the zeros is first, okay? Zeros is also known as the roots, the solutions of the polynomial. So the things we just found in that last section, those are all called zeros. God bless you. And if it's a real root, if it doesn't have an I on it, then it's an x-intercept. If it has an I, you won't see it on your graph. It's still a root, but you won't see it on your graph, okay? It's not a real root. If I had like -2 and +1 as roots or as solutions to my equation, then I know it's going to have an x-intercept at that point. The multiplicity tells you what happens at that x-intercept. If a root occurs more than once, which is why it was important in that last homework question, and it occurs an even amount of times, it's going to hit the x-axis and turn at that point or bounce off the axis at that point. If it occurs an odd amount of times, then it crosses through the x-axis at that point. So if I had a graph and I knew the end behavior was like rises left and falls right, and I know it has -1, which occurs twice, and it has a +2, let's say, as roots, I'm going to go to my graph where it says -1. I'm going to come and I'm going to hit it and bounce off of it, and then I got to come back through +2 because it says it crosses through. So this is what a bounce looks like because it's got a multiplicity of 2. And this is what a cross through looks like because it has a multiplicity that's odd or 1.
How do you know how high to go?
We'll find more points. So like just having the y-intercept there would tell me where I got to cross through, and it gives me an approximation. And then if I didn't have anything else, I would just like plug in 1 and see how high that point is. And sometimes they're going to be super high, so you like just plot the point and label it. Like I don't need you to go to like 1 and 42. It could be that high, depending on your graph. All right, so this one says find the end behavior, the zeros, and the multiplicity. So the first thing I'm going to do is make sure it's in decreasing degree order, which it is. Then I look at my highest exponent, which is what? Odd, and the number on the front, positive or negative? Positive. So if it's positive odd, what's my end behavior? Falls left, rises right. Then it says find the zeros and the multiplicity. So I'm just going to solve it. I'm going to make f of x 0. So 0 equals x to the third plus 2x squared minus 4x minus 8. And there's 4 terms, so my first attempt is going to be factoring by grouping. I can take out the x squared and take out a negative 4. And I get x plus 2, x squared minus 4, which is x plus 2, x plus 2, and x minus 2, because x squared minus 4 is the difference of 2 squares. And then set each parentheses equal to 0, and I get negative 2, and positive 2. So now when I list them, I only list them once, but I write their multiplicity if it's not 1. So I do like a little 2 and just circle it like that. If you see this as if it was like multiple choice, it'd be written in words. Negative 2 with a multiplicity of 2 is how you would see it. I think that's how it is on website. Oh, no, it's not. Tonight's on website. And then the positive 2, you don't need to put the 1. The 1 is implied. If you don't put something else, you're saying it's only occurring once. But if you put the 1, it's not wrong. Huh? Yep. Yeah, so if this is an open-ended question, which it will most likely be, you'll just see the line for the roots with the multiplicity, and you can write it like that. If it was multiple choice, then it would be written out as x equals 2 with a multiplicity, negative 2, sorry, with a multiplicity of 2, and x equals 2 with a multiplicity of 1.
But it's also we have to like label like if it's like the behavior, or do we just have to graph it?
Say that again?
Like do we have on this with like false left, rises right, or do we just graph the?
It will be both. Like it could just straight up ask you for end behavior, or it could be part of your graph. So if I was to graph this by hand, I would start with that information. I would start by plotting my zeros, and then knowing my end behavior falls left and rises right. I know it bounces at negative 2, so it's got to come down. I don't know how low yet. We're not there quite yet. But it's got to turn around and come back up to be able to cross through. So again, if it told you to find the intercepts, you're also going to find the y-intercept, and that would tell you how low to go right there. Questions on that one? All right, so here kind of takes it to the next step. So determine the end behavior, which is what we've already done. Find the zeros in the multiplicity, already did. Now I would say next step is find the y-intercept. How do we find a y-intercept? Good. Make 0, make x 0. And then plot any additional points. So you need 1 point in between each pair of zeros. If the y-intercept isn't enough, then you just pick a point and plug it in. So if I have 2 zeros, I need 1 point between them. If I have 3 zeros, I'm going to need 2 points, 1 between each pair. All right, so it says graph using what you've learned in this section. So I'm going to take this. I'm going to start with end behavior. In decreasing degree order, highest exponent is even or odd? Odd, and positive or negative? Positive. What's that tell me about my end behavior? Good. Falls left, rises right. Then I find my zeros. So I set it equal to 0. Can I factor by grouping? Nope. Which tells you what? I got to find the possibles and test the possibles to see which ones work. So I go plus and minus, factors of last. Luckily, it's just 1 and 6 and 2 and 3. Factors of first is just 1. So plus and minus 1, 2, 3, and 6. Take a negative 1, put it on the outside. Doesn't work. Take a positive one, put it on the outside. And that one works. So my first 0 is positive 1. Take what's left here. This gets an x and this gets an x squared. See if you can factor it. Can you? Yep, factors of -6 that sum to -1. -3, positive 2, which means my remaining roots are positive 3 and -2. Do any of them repeat? No, so the multiplicity of each is 1, which means it's going to cross through each point. So far I have those things. What am I going to find next? The y-intercept. So I plug 0 in for x. I get 0 to the third minus 2, 0 squared minus 5 times 0 plus 6. And all the terms with the x's cancel out, and I'm just left with 6. Yeah. Say that again. Would it work? Yes. Yep. Just make sure it's not like, sometimes it'll be in like, almost like a standard form where it's like x minus 6 squared, like that. That doesn't work. But if it's already FOILed out like this, then it works. Yeah. Yeah. It is. It's up here. Yeah. All right, so now I'm going to list them. I'm going to plot all that information. I'm going to do a 0 at 1, a 0 at -2, a 0 at 3. My end behavior is down left, up right. My y-intercept is 0, 6. With me so far? Crosses through each of those points. So I know it's going to come up, hit 6. I don't know if it's going to go higher or lower, but I have that 1 point in between my two pairs, so it's okay to turn it at that point. Comes back down, has to cross through 1. Now, I don't know how far down to go here, which means I'm going to plug in 2. So I'm going to plug in that point that's in between those, which is 2 for this time. And I plug in 2. So 2 to the third minus 2 times 2 squared minus 5 times 2 plus 6. So 8 minus 2 times 4 minus 10 plus 6. 8 minus 10 plus 6. These two are gone, and I get -4. So I have a point at 2, -4, and that tells me how far down to make my curve go in between those 2 points. And I know it has to cross back through, so it's got to turn around and come back up.
What if you have a point at the 2? Like, where would you go? Like, would you go, like, more up?
You'd have to plug, no. So you know it crosses through here. I know it has to come down. I just don't know how far down it comes before it comes back up. So it has to, if it matches, it has to match a multiplicity. So if it's odd, it has to cross through. It doesn't matter, like, I'm telling you to get an extra point there, but if you didn't have an extra point there, you would kind of just estimate how low it goes. Questions on that one? Yeah.
Do you always plug in 2?
You always plug in a point in between your zeros. So this time I had 1 and I had 3, so 2 was an easy plug-in. If I had like 1 and 8, I would just plug in something in the middle-ish. You could, yeah, Yeah, it's not fun, but you can. All right. Let's do it again. In decreasing degree order. Yes. Highest exponent. Odd. Positive or negative. So what's my end behavior? Falls left and rises right again. Is it factorable? Can I take the same thing? Nope, right. No. So we go back to so my first this time is 1 and 2. My last is 1, 12, 2, 6, 3, 4. So my possibles, plus and minus, 1 over 1, 2 over 1, 3 over 1, 4 over 1, 6 over 1, 12 over 1. And then all of those go over 2. So 1 over 2. 2 over 2 is 1, and we already have it. 3 over 2. 4 over 2 is 2, and we already have it. 6 over 2 is 3, and we already have it. 12 over 2 is 6, and we already have it. So here's my possible bank. So if we didn't have a graphing utility, we would have to go from there, right? And we would have to test all of our possibles. We're going to cheat, and we're going to look for a root on our graphing utility just for time purposes, okay? So take out your graphing calculator and type that sucker in. All right, so again, we cheated just for time purposes, but we're going to just from this graph get one root. There's two ways to do it. One is look at your x-axis and see where it crosses through. The second is hit the table feature and look for where your y is 0, okay? If there are whole numbers, they will be there. So let's just grab this first one. This would be -1, this would be -2, this would be -3. So if we had tried -3, we should have got a remainder of 0. So -3 on the outside and 2, -1, -25, -12. Bring down the 2. And there's that first root. So -3 is one of the zeros. That's my remainder. This gets the x squared. 2x squared minus 7x plus 4. Now let's see if it's factorable. So we can multiply first times last. 2 times 4 is 8. Are there factors of 8 that sum to -7? Oh, this should be -4, sorry. That should be -4. So -8. And the answer is yes, right? -8, +1. Replace the middle term with them. And then factor by grouping. Take it a 2x. And this one's already x minus 4. So the remaining roots, or the remaining factors are x minus 2 and 2x plus 1, which means my remaining zeros are 4 and -1/2. So I've got the -3 from the beginning, the 4, and the -1/2. Now I'm going to plot those points. So -3, 4, and -1/2. And we're going to pretend like we didn't just see it graph, because you wouldn't if you didn't have your graphing utility. I know my arrow points down on the left, up on the right. I find my y-intercept by plugging in 0, 0, 0, which means my y-intercept is 0, -12. Off my graph, but I'm just going to mark it as low as I can go and then label it. So that's my point in between the -1/2 and the +4, but I don't have a point in between -3 and -1/2, so I'm just going to plug in a point. You can either plug in -2 or -1, it doesn't matter. They're both like midway-ish through. If there was a dead center, I would plug that in, but we're just going to plug in. So I'm going to plug in -1 because that's easier. 2, -1 to the third, minus a -1 squared, minus 25, -1, minus 12. 2 times -1, minus 1, plus 25, minus 12, -2. And I get +10. Again, not on my graph, but I'm going to plot as high as I can go, -1, 10. And now I know my graph comes up to there. It's going to have to turn around and come back because it's got to cross through the -1 and go all the way down to -12. And then it's going to turn around and come back up and cross through +4. So notice that like on the actual graph one, it kept going down after the y-intercept, and our graph doesn't exactly model that, but as long as your graph is one approximation, two, you have a point in between the two zeros, so negative 1/2 and positive 4, this is good enough for me. First of all, for me, if you can plug, like if you needed to know exactly where to go in between the -5 and the -4, you would plug in like -4.5. I'm going to tell you that if it's not a whole number in between, you could just estimate, okay? So it doesn't usually go too far if it's only one away. You can kind of just go down a little bit and mark it. You don't have to plug in a decimal. But if you did need to, like if this was, let's say it was multiple choice and there was two that looked very much alike except for that one little spot you needed to plug in a point, then you would plug in -4.5, okay? But as long as you can get the rest of that, you don't have to. If there's not a whole number in between these two zeros, I'm fine with you just approximating how far down to go.
Can we calculate this real quick?
No. So it's going to be part and part. Yeah. Which we'll get a little bit more practice with tomorrow. Like you'll see exactly how it would be, what you have to find using the calculator. This kind of a question may not be because those are all whole number roots. You could just find it the other way. Here, and then we'll save some of those for tomorrow. So this is example 7. Now this time the format's a little different, right? It says f of x equals -x minus 3 squared times x plus 1 times x plus 1 squared, using what you've learned in this section. So the first thing is you got to figure out end behavior, and this is in a very different format. You do not need to multiply those all the way out to figure out your end behavior. Think about what would happen if I took this and I raised it to the second power. What's my highest exponent going to be there? It would be x squared. If I took this and left it alone, that means I'd multiply by another x. If I took this and raised it to the squared, it means there'd be another x squared, right? And the negative on front means at the end it would all be negative. So if I took just those exponents and multiplied them out, I'd get x squared times x to the first times x to the second, which is -x to the fifth. So I don't have to multiply them all the way out to figure out the end behavior. You can use that, right? Just take the first term, whatever's there, raise it to the power of that parentheses. So that first one would be an x squared, the second one would be just x, the last one would be x squared. Multiply it out and then look for the sign at the front. So if it's a -x to the fifth, what's my end behavior? Good. Rises left, falls right. Now to find the zeros, it's perfect. It's already set up, factored out. So all I have to do is set each of these equal to 0. and I'd get an x equals 3, and there's 2 of them, so there's my multiplicity. I'd get an x equals -1 here, and then -1 here with a multiplicity of 2, which means there's a multiplicity of 3 on the negative ones. Now, the catch is that the y-intercept isn't as easy to plug in, right? Now we've got to actually plug them in. So -0 minus 3 squared times 0 plus 1 times 0 plus 1 squared. This is my y-intercept. So I'd get -3 squared times 1 squared. -9 times 1, which is -9. So I've got a 0 at -1, and there's 3 of them, which means it's going to cross through. A 0 at +3, and there's 2 of them, which means it's going to bounce. And a 0, -9 for my y-intercept. So it rises left. It's going to cross through here. It's going to come down and hit my y-intercept. It's going to come back up, and it's got to bounce here because it has to fall to the right. This time only 2 real zeros, so I only needed 1 point in between, and my y-intercept was that point. So it saved me the time of having to actually plug that in. All right, this just says straight up, use the graphing utility to graph f of x equals parentheses x squared plus 3, x minus 1 squared, and plus x plus 4. Oh. Okay, so I typed it in. I went to the y equals x squared plus 3, x minus 1 squared, and then x plus 4. And then I go to graph. So from my view as it is, that's what I get. It's definitely cut off at the top. If I wanted to see more of the top, then I can do 2 things. One is zoom out. I hit it again, and it's going to zoom out. And it's still cut off at the top. So I would go zoom out again. And it's so hard to see at that point. So this is one of those situations where I would try to mess with my window instead of zooming out, because that makes it almost impossible to see. So if I just go to my window and I set it back to the original, which is -10 to +10 for each of these, and I go back to my graph, the x left and right is fine. I get my full graph there. The problem is the y, right? So I can just go to y equals, and I can, oh, sorry, not y equals. I can go to my window, and I can change my y max. Let's just change it to 50 and see what we got. I could do it again, window. All right, so I finally got the max there, okay? I have my whole graph. So the things I can figure out from this graph are my zeros. I can find my max, I can find my min, I can find my y-intercept, all those things. To find the zeros, remember, if they are whole numbers, I go second table, and everywhere the y is a 0, so there's a -4. That's a 0, and there's a +1, that's a 0. Here and here, okay? If I go back to my graph, notice that it's crossing through that -4 and it's crossing through that +1. So it's consistent with what we just found. If it had crossed through other points that were not whole numbers, then the way you find those zeros is you go second, trace, you get to your calc menu, you go to 0, which is the second thing. If I wanted to know what that 0 was to the left, I would go past it, anywhere past, which is here, is fine. Then right of it, and then hit enter on the guess, and it's going to bring me to that -4, 0. if I do the same thing on the right, and sometimes this is where it gets weird because it doesn't know a change. Let's see if it'll catch it. As long as I'm left of it and then right of it. There it goes. It brought me to that one. Sometimes it won't be able to find it because it's not enough of a sign change, but that one it did, okay? If I wanted my y-intercept, I go second, trace, and I go to value. Actually, I can go to, yeah, I go to value. And my y-intercept is where x is 0. So I literally plug in 0 there. And it brings me to my y-intercept, which is 0, 12. So although it looks low on this graph, it is at 0, 12. And then pay attention to end behavior. This is a positive x squared. This would be a positive x squared because of the 2. And this is a positive x, so I get x to the 5th. Positive, which means it falls left and rises right. So it's consistent with what we found. This goes all the way up way high, but again, we're making an approximation here. Our zeros were here. This would be the plus and minus the square root of -3, which is why it's not on my graph, because it's a imaginary number, right? It'd be plus and minus I root 3. This is a positive 1 with 2 zeros, and this is a -4. So it should bounce at positive 1. It should cross through at -4. So all the things we learned about end behavior, about zeros, all that stuff should be consistent with what you're seeing on the graph. Questions on that one? Tell me what you know about this graph without graphing it. Falls left, rises right. Okay, then you go to your graph. Type it in. I want to reset my window. This time the y-intercept is really low, okay? So I know that it has an x. It looks like the x-intercept is at -3 or 0 at -3, and it looks like it's at +1. Falls left, rises right, which is consistent with what we said. If I want to find to double check those zeros, I would go second table. There's my -3. There's my +1. If I wanted to find my y-intercept, I go second, calc, go to value, and make x 0. And my y-intercept is all the way down at -45. Which is consistent with plugging in zeros, right? I could have gotten that from my equation. Then if I had actually found the possibles here, worked it out, I should have found that it happens an even number of times for -3, comes down, comes back up again, and it would be an odd number of times for +1. So let's just say it wanted you to actually find all the zeros, right? Using your graphing utility. You would use your graphing utility to get 1, 0. Like, for example, let's say +1, because that's an easy one. I would put that on the outside. This would be 1, 5, 8, 16, 15, -45. Bring down the 1. That's one of my zeros. This gets x, x squared, x to the 3rd, x to the 4th. I can't factor it yet because it's x to the 4th, so I would try another 0 like -3 and bring down the 1, the 6, the 14, the 30, the 45. This time, I can factor by grouping. So here's my other 3 and it bounced, right? So it makes sense that there would be an even amount. And then x squared would equal -5. X would equal plus and minus the square root of -5, which is plus and minus I root 5. And that's not on my graph, which again is consistent with what we found. So we had a 0 at 1 with a multiplicity of 1. We had a 0 at -3 with a multiplicity of 2. And then the other roots were not real roots. And then our y-intercept was 0, -45.
Can you show how you got the y-intercept again?
On the calculator?